Hi everybody, so we'll be starting with this chapter H2SO4, that is sulfuric acid. It is also known as oil of vitriol. We'll be discussing about the general methods of preparation, then the contact process, which is the most important thing in this entire chapter. So let's see, general methods of preparation. Here we react S plus HNO3, that is your nitric acid, you already know about it. So I'll just not take the name of the compounds because I have to make this video short. Then NO2, H2O and H2SO4 is formed. Then we react SO3 plus H2O. Again, it forms H2SO4. And also, I have launched this chemistry ebook that you can check from the link in the description box. It has got all the handwritten notes of all chapters along with the chemistry reactions. So you can refer to that if you want proper notes for your board exams. Then contact process. First, we'll have chamber conversion. What happens here is sulfur plus oxygen gives SO2, right? Then FeS plus O2 gives Fe2O3 plus SO2. Now this sulfur dioxide is added with oxygen and it forms SO3 plus heat. The catalyst here is vanadium pentoxide. You have to mention the catalyst, temperature and the pressure involved. Then absorption tower. In this SO3 plus H2SO4, it forms oleum, right? In the dilution tank, we add water in it to form H2SO4. Please balance all the reactions whenever you write it. In case you're not able to do that, you can also refer to the reactions video of Physics Wala Sir. See, sulfur or pyrite burners. Now we'll talk about each and every unit. So here, S plus O2, it's forming SO2. It burns with pale blue flame. Okay, you have to mention this. You have to remember it. Then purification unit. Now this gaseous mixture of SO2 and O2 contains impurities like dust particles or pyrite dust. So how to remove these impurities? See, what happens is when these impurities are there in this compound, it poisons the catalyst and also it reduces its efficiency. So dust particles are removed in the dusting and scrubbing tower and the arsenious oxide impurity in the arsenic purifier. So these are the things that are involved to remove the impurity. Then we have contact tower in which SO3 is formed, right? Around 450 to 500 degrees Celsius is the temperature. The excess oxygen favors the forward reaction, thereby enhancing the yield of sulfur trioxide. So when there is this excess oxygen, when you balance it, you will come to know it favors the forward reaction. Then only the reaction can proceed. So catalyst. Here we use V2O5. Why? Since it's cheaper and also less easily poisoned. V2O5 is mixed with a promoter using potassium oxide to enhance the activity of the catalyst. You have always seen that we add a promoter to the catalyst in order to enhance the activity so that it becomes more efficient, right? Then we come to the temperature, which is 450 to 500 degrees Celsius. This is the most suitable. And it also helps in exothermic reaction. The pressure here, the forward reaction is favored by increasing the pressure if a reaction takes place with decrease in volume. Hence, जो high pressure है आपका, it favors a higher yield of sulfur trioxide. Okay. See, here it is written. High pressure favors a higher yield of sulfur trioxide but may cause damage to the lead pipes. Now absorption tower. The SO3 vapors are absorbed in concentrated sulfuric acid and not in water. Even though SO3 is an acid anhydride of H2SO4, it is not directly absorbed in water to give sulfuric acid because the reaction is highly exothermic, resulting in production of dense fog of H2SO4 particles. Right? Here we can't directly absorb it in the water. This reaction is highly exothermic. We'll have to take care about it. Now, we'll talk about all those reactions like sulfuric acid as an acid when dilute, right? So these reactions are in my chemistry ebook. I feel that I'll just brief you about this, but you have to learn all of them yourself. What happens is when sulfuric acid and water is reacted, hydronium ion is formed along with this sulfate ion, right? See, when this is dilute, this is the displacement reaction that's taking place. Then SO4 plus hydrogen is released. Then we see Na2O, NaSO4 plus H2O. So these are the displacement reaction. See, board will be framing question like this: sulfuric acid as a basic acid, write reactions for this. Or maybe sulfuric acid as a least or non-volatile acid. You'll have to write the reactions for that. Now NaCl plus H2SO4 when concentrated gives NaHSO4 plus HCl, and the temperature here is less than 200 degrees Celsius. So you'll have to write the reactions accordingly. For example, it's written as an oxidizing agent. So you have to show the oxidizing property of sulfuric acid. Like carbon plus H2SO4, it forms carbon dioxide, water, and SO2, sulfur dioxide, right? So this is how you show the properties of sulfuric acid. Now, as a strong dehydrating agent, concentrated sulfuric acid is added, it forms carbon plus water. So you'll have to show all of this. All these reactions are in my ebook. You can check out the link in the description box. In that chemistry ebook, it has all the reactions, all handwritten notes, numericals, and everything is covered. Thank you for watching this video. I think the reactions are something that you have to yourself learn, and I'll be uploading more such chapters. All the best. Bye.